and that is 997 we have, right? So let's understand the question, what question is saying. So we have 997, right? And we have to find the town judge, right? So how we'll do that? So in town, we have to understand first question, right? So let's read this question. In a town there are n people level from 1 to n. Okay, so there is a rumor that one of these people is secretly the town judge. Okay, so we have to find the town judge. Who is the town judge, right? If there is from 1 to n, we have people in a town, so we have to find which one, who is here in this array. We have a judge, right? Means from 1 to n people is nothing but a array element consider, right? Now we have to find if the town judge exists. Then the town judge trust nobody. Town judge trusts nobody. Second, everybody trust the town judge except the town judge, right? And next, third, we have there is exactly one person that satisfies properties 1 and 2, correct? You are given an trust and trust of AI and BI, correct? Represent the person level AI trust person BI. Then we have to return the level from the town judge if the town judge exists and can be identified, or return -1, correct? We have to return what? The level of town judge if the town judge exists and can be identified, or otherwise we will return -1. So let's suppose here example 1 and see. Now what we have given? We have given n equal to 2, right? And trust we have given a and b. Let's suppose a and b. A is nothing but what? 1, and b is nothing but 2 we have given. So it is saying it a is trusting what? B, because only two elements we have here, right? So if a is trusting this one, right? So the first condition, town judge trust nobody. A is trusting to B, correct? But B is not trusting to A, right? And that's why say B is a judge, right? Town judge. Next, let's see, consider example second, in which we have given n equal to 3, right? Means we have 1, 2, 3 element we have, right? But trust we have given how? Trust we have given 1, 2, 3. 1 trust 3, 2 trust 3, right? But 3 not trusting anybody, and that's why we are getting what? 3 as the output. Similarly, if you see, consider example 3, this one, right? So what we have given? N equal to 3 we have given, means 1, 2 and 3 we have given. So it is saying 1 to 3, correct? 1 is trusting 3. Now 2 is trusting 3, correct? Now what can I saying? 3 is trusting 1, correct? So there is no one that trust not trusting anybody, right? And that's why means we are getting noses in this town. Okay, no, in this array, in this example. Okay, I think you have understood the question, right? So we have understood 3 examples. So let's begin and understand the approach, right? So we have first approach, in which what we will do, the trust relation that form a graph, right? Let's suppose. So what we will do, we have a trust pair that contains what? Trust pair contain A and B, correct? Like this we have given, because this trust contains in array, right? There can be more than one element like this, and more than, right? We can take here. So let's suppose we have only one element A and B, correct, in the trust. So let's suppose trust form a graph, correct? Let's say that represent, we can say this trust A and B is a directed edges, right? Means if we are trusting like this, right, A and B, so this is direction. We have a direction here, right? So for example, if we have n equal to, suppose we have given a 5 element, right? So if I consider, we can take one, we have element 1 to what? 5, correct? Because we have n equal to 5 we have taken. So if I'll take 1 3 first, next we are taking 2 3, next we are taking 4 3, next let's suppose we have 4 1, correct? Next we can take 5 3, then we will take 5 1, and let's suppose we have 5 4. As you see, what I have taken this array from here to here, right? How many trusts we have? 1 2 3 4 5 6 7, right? 7 we have. If I'll represent this one, so first I'll take here a 1. Let's suppose we have 1 I'll take 2 here, 3 here, 4 here, and 5 here, right? Total 5 we have. And give me 1 minute, I'll change the pen. Yeah, now you will see that first what we have, 1 2 3, right? So 1 is going to make a direction here, right? A trust directed is we have created. Now 2 to 3, now we have 2 to 3, 1 to 3 we have, and 2 to 3 we have, correct? Now we have this is done, this is done. Now 4 3, now we'll make a direction 4 3. Now we'll 4 1, right? 4 3 we have done, 4 1 that we have done. Now we have 5 3, and we'll go here. Now we'll take 5 1, we will make here. Now we'll go 5 4, 5 2 4 will go, right? So as you see, based on this given trust, what we, this is our trust, right? So we have trust here. For all each trust we have make a graph, and based on this graph, as you see, everyone is trusting each other, right? But as you see here, 2, right? 2 is not trusting anybody, correct? 2 is not trusting anybody in this example, right? So we can say 2 is our judge, right? But if we'll take an example, let's suppose, let's go to here. Okay, let's suppose what we have given another trust. We'll take 2 1. Okay, then we will take 3 1 4 2, and we'll say 4 2, and we'll say 1 4 3. We can make 4 5 and 5 1. Let's draw this graph. So if we have what, 1 we have, 2 we have, 3 we have, 4 we have, 5 we have, like this, right? So if we'll make this graph, let's see, 2 is going to what, this one, right? 5 is going where, here, right? And if you'll see, like this one, we'll make we are making like this one, right? So I have taken 5 making this one 1, 4 making what, 5. So we can make like this one. Then we'll do 4 3, 4 3, 4 is going to here, this is done. 4 2, 4 is going to 2, and 3 1, 3 2 1, we are going like this, right? So here also, if you'll see, there is we have 1, correct? From 1 we are not going anywhere, right? So we know that everyone is coming to 1 and everyone is going to each other, correct? But this one is not going anywhere. Okay, and so we can say this is our judge, right? We can say. So there can be one more possibility. If I'll let me change the pen. Back to it. Yeah, so let's suppose we have given we will make directly graph, right? We have 4 here. Let's suppose we have 1 2 3, and we'll take 4. Sorry, 4 we have taken, we will taken 5 right here. So if 1 is pointing to here, right, means we have what, 1 4, suppose. Next we have what, let's suppose 4 is going to 2 here, means 4 2, correct? In the trust, this is our trust. Next, suppose what we have, 3 is going to 2, correct? We will say 3 2. Next we will take what, 2 is coming to 4, like this. So 2 4 we can say, correct? Now what we can say, 5 is coming to where, here, correct? So this is a 5 4, and one more condition we will take, this one. So 3 4. Now you can say that 5 is coming to 4, 1 is coming to 4, right? 2 is coming, 4 is going to 2, and 2 is going to 4. So this, if we consider this example, right? So which one is the judge, right? So everyone is going to each other, right? We cannot say 4 is not a judge, right? Like this we can say. Okay, if we consider everyone is coming to, like 3 is coming to 1, 5 1, and 3 is coming to 4, right? and similarly this is going to 2, correct? So we cannot say that this is our judge, 4 is judge, right? Because 4 is going to 2 and there is no judge, right? So as you have seen that, right, like for this example, right, the town judge 3 we have, right? Town judge 3 we have, because if you say, because they are trusted by all other, right? 1, 2, 4 and 5, right? They're trusted, but they don't trust anybody themselves. They are not trusting anybody they are not trusting, right? For the first example that we have seen, uh, this one, right? For example 2 that we have seen this one, right? There is no town judge, correct? We have seen this one. And third we have already seen there is no town judge, correct? While in this example 4 is trusted by everyone, but 4 trust themselves, sorry, 2. Therefore 4 can't be a judge, town judge. There is no possibility, we don't have town judge here. I think we have completed this thing, right? So what we should do now, we should go and we should make uh, what this relationship, right? So let's suppose this is the thing we are talking about, right? So, in the graph theory, if we'll come here, so in the graph theory we say out degree, right? There is a concept out degree. Okay, so uh, out degree of a vertex, out degree of a vertex, if you remember, right, of a person we will take, right, of a person we will take. So we say that the out degree of a person vertex, right, person is a vertex right here, is the number of directed is going out of it. Like, so someone is going to from here to here, let's suppose, right? So we can say what the out degree, what is the out degree? Out degree of a vertex, that is person, is the number of what directed is from going out of it. Let's suppose one is going to 2 here, 2 and 3. Okay, so what is the out degree? We have 2 out degree for 1. This is for, there is 2 out degree, if we'll consider, right? The 2 out degree we have. So for this graph, right, that we have seen just, what we will do, out degree of the vertex represent the number of other people that trust that S. And so likewise we can say that that in degree of a vertex is the number of directed coming into it, right? So if you consider for this one in degree, right, so in degree is 1, in degree of 3 is 1, we'll say consider. But even consider in this example, so in degree 4 is what, 1 2 3 4, 4, there is 4 have in degree, but out degree is what, only 1, that is going here to 2. Got it? I think you have understood in degree and out degree also, right? So therefore the problem that the town judge has what, out degree 0, if you consider for the town judge, for the town judge, right? What should be the in degree, right? So out degree, if you consider for the town judge, it should be what, 0, right? And in degree can be in, if you talk about in degree, it can be what, 0 to n minus 1, we'll say, or we can say n minus 1, because this is only one node and we have given what, how many node we have given, what is we can say vertex, total vertex we have given n. So if there is one judge, this n minus 1, correct, we can say. Is it fine? Now because they trust nobody and everybody trust them except themselves, right? So there can be possibility of n minus 1, right? Now, therefore, the problem simplifies to calculate the in degree and out degree for each person and checking whether or not any of them meet the criteria of the town judge, right? We will do that. So we can calculate in degree and out degree for everybody using a single loop we can take over the trust array. So we will write the result into two array, you can say. So let's suppose we have I'll take here. Okay, so uh, better we'll go to next page here. Yeah, let's suppose we have given what we have given integer like this. Okay, and it is not what we have in degree we have given. So if we'll take in degree, so I'll take, if we'll initialize this one, so it will go to n plus 1. I'll consider the possibility, right? In degree can be the possibility n plus 1 will say. And similarly I'll take int, but this is our out degree. Let me write, no problem, int this one, right? So for this one, what will happen? This will remain same, correct? New int in degree we will take, no problem. But for, if we'll go to for loop, right? Because see, we can calculate the in degree and out degree for everybody using a single loop, right? Over the input trust array. So what we will do, we will make we have trust, right? Let's suppose we have trust here. This is trust. So from each trust we will get one relation, right? So I'll take this is a array and this is our relation, right? We'll say relation. So what we will do, we will take out degree like this degree, and we will say what we'll take two things. We will pass our relation here, and relation at let's suppose relation at 0. Relation at 0 will take here, and we'll say this is plus plus. And if we'll talk about in degree, so I'll take in degree and we'll pass what relation at what 1, and this will say plus plus. This is also plus plus. In degree and out degree we will implement, right? But if we done this one, so we will have our each relation have what relation, relation at 0 what we have, relation at 1 what we have, and we will calculate our in degree and out degree. We will do the plus, right? But one thing we have here, like after this, then we can simply loop over a people, right? These things we have to make on the loop, right? 1 to n we have n people, we have 1 to n people we have, right? Correct. And 1 to n people number we have got. So for the loop over these people 1 to n, right? What we will do, we will check whether or not they meet the town judge criteria. How will do that? Let's go to here and we'll say we have make a for loop, right? And we will check int I equal to, we will start from what, 1 to n. Let's suppose 1 to n we will go. Less than n we can say, we'll see that. Okay, we'll go to 1 to n. And what we will do, for each in degree I will consider, if we have in degree, right? Now we have in degree at a certain position, that is person I, for the person I. So in degree for the person I, we will say if equal to n minus 1. Got it? And one more condition we will check here only, in the same condition, out degree of this person only if equal to 0. Simple. Then what we will say, return this person. I think you have understood, right? Then we will return this person. Otherwise we'll come to the else and we'll say return what, minus 1. We don't have any judges. So this is the final example that we will we will put onto the yeah, that one, what do we say, our relation that we have here. So for all 1 to n we have to make this loop, and then we will do. And then if we want to do optimization, right, we can make to observe that it is impossible for there to be a town judge if there are not at least n minus 1 edges in the trust array. What we will do, this is because a town judge must have n minus 1 ingoing edges, we can say. So if there aren't at least n minus 1 is in the total, so what we will do, then it is impossible to meet the requirement, correct? So this observation will also be very useful when we are going for we are reasoning out the time complexity, will say, right? So if you understand, like if trust is less than equal to n minus 1, right? So what we will do, we will return directly this one. So we can make one condition and we'll say that trust dot length, if trust dot length is less than n minus 1, right, then immediately we will return what, minus 1 we will return here. after checking this condition, if trust dot length is less than -1, correct? So let's go to the prompt section and we'll understand what I'm talking about. Okay, so let me go to the browser. Oh, sorry. So here we are at this code browser, okay, of the Leetcode. So let's go and understand. So we have given n number of people we have given, and the trust relationship of the array we have given, right? 2D in the 2D array. What we will do first, as I told you in the last, what we will do first of all, we will say trust dot length. Sorry, this is not for, this is if. We should first check always if trust dot length, this one, if it is less than what, n minus 1. If trust dot length is n minus 1 less than 1, then what we should do, immediately we should return what, -1. Remember why we should do, because uh, we know the total judges should have at least the trust length should be less than equal to n minus 1 only, right? If that is more, there is some issue. And so we will come to the next, then we will initialize our, let's see, as I told you, we will take in degree, we'll take in degree, and similarly we'll take new, and we'll say int, right? And we'll take what we have this is not in the capital, so we'll say n, and similarly we'll say n plus 1. This is done. Similarly we will get our out degree, and so we are here, we can say this is our out degree. Both is done, in degree and out degree. We have initialized in degree and out degree. Now what we should do, as I told you, we will move to for loop, and we'll go for all the relation. So we have given trust, as you see, trust we have given. From the trust we will get what, one by one relation we will get. So there will be, for each person there will be a relation, right? So I'll take for each person, each pair, from the trust we will get to, from the 2D array we will get one D array, you can say like this, or each pair we will get of the trust, right? For each person, you can say. Let's suppose we have out degree. First we will say this person have out degree, what, and this have, for this relation, in this relation out degree is at 0. What is the at 0? So at 0, what we will have, if it is coming 2 times, we will increment this 2 times, okay? If not, then we will say out degree we have calculated. Now we will calculate in degree a relation at what, 1, means we will, from this is our a, you say we are talking about a, and this is our b, we are going from a to b, correct? Like this we'll say. Now if we'll come to like we see, for each trust is like what, trust was like this was array, and it is coming what, a and b, correct? So for a it is going to b, right? So this is at index what, 0, and this is at index 1, and so for all the relation that have, right, a we will increment plus plus, and in degree will do plus plus, right? That we have. Now what we should do, for these things should be we have to overloop on all the person. So let's see, we have person, and we can say person is I, right? And say person equal to 1. Let's suppose we have person 1, and from we will go to what, last person. Last person is nothing but sorry, n, right? Last person is our n, so we can say less than equal to, we'll say that. If we'll start from there to there, right? For all the person we have to go, right? And this I is nothing but our what we have, our person we have, right? I'll take either we take person or I, and then we'll say person plus plus. But you have to understand, now you have here everything. Now what we have to check, the condition we have to check for the judge. If in degree at what, the person in degree, if this person is what, is judge, means what, n minus 1. right? This is the last person we should have, and as well as another condition I told you, out degree, right? Out degree at what? That person, out degree of this person should be what? Equal to 0. There should not be out degree. And so we will return this person. We'll say this person we have to return as a judge. This is our town judge. Okay, we are returning town judge. Now if this is not the case, so finally we have not found our judge, then we should return always -1. Let me compile. Oh, sorry, I'm taking minus. No, oh, it's working. This one, right? We can say, yeah, it should work. Just a space was there. So this is working, I think. Yeah, and I'll try to optimize in 1D array. Okay, this is our 2D array program. I'll try to implement into 1D array. So please like, share, subscribe this video, and stay tuned for the next video for 1D array. Okay, and please subscribe for more videos, and thank you for your love and support.